Hi, my name is Andrew McLaren, and I want to help you really understand the circle formula beyond just like memorizing it. Now, the standard form that we draw right here is a bit weird for most students to fully wrap their head around. So we're going to look at it with a number of examples. But if you see this as something kind of like a change in x plus a change in y that are being squared, that is equal to this radius that's being squared. In another sense, you have a triangle that's being traced around this origin where there's a different combination of change in x and change in y that will give you this radius. In other words, this looks like a squared plus b squared equals c squared for some sort of triangle. Um, and you can imagine like there being a circle where this triangle has some sort of combination of x and y values that work, um, like kind of like that, or it could be like kind of like that with that to make like a different triangle. So there's all these different combinations of like x and y essentially that we're talking about. So if we're talking about this guy right here, there's an arrow triangle there, and you're combining like different x and y values to give you that radius when you were to square those values. The easiest way though to think about this is just with a couple different examples. So if that part of what I just went over was just went over your head, don't worry. I've got other stuff that really helped one of my students who was just not really getting why we do the standard formula or how it works. So we're going to start off with the most basic of this version. If you have like x squared plus y squared equal to 1, you can think of that as something that we're going to plot out. And we can plug in like x and y values and see what ones would solve for this. So for example, if I said x is 0, 0 squared plus y squared is equal to 1. And you can see that y, if you were to have that as 1, that kind of works. Now, if you're familiar with the circle formula, you should recognize that this circle is going around the origin, but you can, for right now, see that if I say x is 0, then y could be 1 or positive 1. If you're kind of thinking about this, there's another combination, another value for y that could work. If you had x being equal to 0, y could be a minus 1. That's another acceptable value that solves for this formula. In a similar regard, if I said, what if x is, or y is 0, then x would have to be 1. So you could say like, oh, if y is 0, then x would have to be 1, or possibly minus 1. Because if you have minus 1 squared plus 0 squared, that is equal to 1, which you could also think of this as 1 being squared if you want. So you can see that this solves for these four values. This circle is kind of running through those values, if you will, at that distance. So you can think about this as like just kind of guess and check. And that radius is telling you, okay, you have to be a certain distance away from the center of the circle. You can also do this with like some other basic numbers. So if we wanted to look at, say, I don't know, x minus 1 squared plus y being equal to 1, we've got the same sort of idea where we can plug in some x and y values with the goal of making one of these things um, not be a number like when we square it. So if we could make it be 0 when we square it, that would be great. So if I wanted to make y 0, then you're saying, okay, I've got now just this x minus 1 squared is equal to 1. In other words, I want to get this whole thing's value in here to be equal to 1. And I can do that a couple different ways. 1 or like -1. So if we're thinking about aiming for 1, you can see that if this was 2, that would solve for this formula. Also, in a similar regard, if this was 0, that would also solve for this formula. So we've got two different points that solve for the formula. We can think of it as x being equal to 2 and x being equal to 0 as two different ways of solving our math expression. In the same sort of idea, you can say like, well, what if I had x being equal to 1? That means that this formula gets a lot simpler in terms of the x component. So if you've got 1 minus 1, that ends up turning this into 0 squared. And then you're just left with y squared being equal to 1. So if we have x being equal to 1, then that means y is possibly a positive 1 or a -1 value. So it might be y plus 1 or y minus 1 is things that solve for this expression right here. So I'll do that in like a light green so you can just kind of see as these two different data points for our circle here. So this circle ends up kind of cutting through these different numbers like so, where it's like, oh, this is a circle and they're all 1 away from that origin. Because we have a radius of 1, it works out kind of nicely. You can do a couple different versions of this to help you see this as well. Just like very simple examples. So if we had, I don't know, x squared plus y minus 3 squared being equal to 1, you can have the same sort of idea that you're kind of doing a test plot and trying to see how this stuff relates. So we can make x values of 0, and if x is 0, then that gets rid of that, and we're just left with y minus 3 squared equal to 1. Let's say that we're doing that. Let's just do that in a slightly different color. Let's do that in a red. So you can see that there's a couple different ways to get this thing to have a value of 1. And so we can think like, well, if I've got 4, that works. And then if I want to make this a -1, something minus 3 would get me to -1. So I think that's a 2. So if we have x of 0, now y could be 4 or 3. If we're thinking about this in terms of the graph, there's an x of 0, and we're saying that there's two different values here that solve for the expression when you have a y of like 2 and 4. Put the 3 in here and the 1 in there as well. So that's like two different points for our data working for solving this expression. You can also see that there's probably something around here and around there just for the circle formula, just to make this a circle, maybe not that far to the right. So that can help you in terms of like thinking through the math, what we're gonna do with the x and y. So in the same sort of idea, let's make it so that the x squared plus y minus 3 squared is equal to 1. Let's try and make it so that this thing's value is 0. To do that, what I'm seeing is that we would need to have y being equal to 3. So when y is equal to 3, that gets rid of that part, and we're left with just x squared being equal to 1. In other words, x would have to be a positive 1, or it could be a -1. And in both cases, we're solving for something that like x and y values that work together to give us an answer to this expression, this general form of this circle. So you can kind of see how the math works. You can also see in all these cases I've worked with a radius of 1, and that just helps you see the distance away from the center point a little bit easier and quicker, and helps you kind of see how the math works behind these. We are going to do one that's a little bit different. Let's say that you have x squared plus y minus 1 squared, but this is now equal to 4. And if you know that this formula is going to be r squared, so our r should be equal to 2. And if you know like, oh, h and k values, how does that work? Then that also can help you just like figure out the plot of this pretty quick. But I'm going to show you this like test plot kind of idea to help you wrap your brain around it one more time. So we do have some sort of x and y coordinates, and we can think of this as like, okay, let's just make this thing's value be 0 just to make it easy. So we've got that x squared is equal to 4. So if we want to make that whole part, the y part of this equation, be 0, y would have to be 1. When we do that, x could be plus 2. So what we're saying is if I've got a y value of 1, and x could be plus 2, that works. But then also, if we've got a y value of 1, you could have a negative 2 for your x. So 1, 2, we've got something here and there where there's a circle going around those. Now, you might look at that and just be like, well, I know that it's going to be 2 higher and 1, 2 lower from here. So you can see that it should be somewhere around here for our data points. But if we're thinking about how that works in terms of the math, think about this as now the x squared being equal to 0. And we're now left with y minus 1 being equal, with that squared being equal to 4. In other words, we're trying to make this thing's whole value be equal to 2 so that when you square it, it's 4 or a minus 2. So if we're thinking about some number minus 1, that's going to work to be 2 when we've got 3 minus 1. If we want to have it be other number, if we want this to work out, you have minus 1, that's got to be minus 2. So that is another way of thinking through this. So if you've got like minus 1, and you square that, you get minus 2 squared, which is equal to 4. Or we could have the 3 minus 1 squared, which is going to be 2 squared, which is equal to 4. So that's another way of thinking through this expression that we're trying to plot out. A little bit of guess and check. Now, the student that I was working with, when I tried to do this with them, they didn't recognize that we were aiming for 2 squared as opposed to just 1 in here. So that was a little bit of a transfer of the simpler problems from just a minute ago. But if you think about the radius should be 2. And I'm seeing a radius of 2 where we are 2 away from the center point. Either sideways we're 2 away, or top and bottom we're 2 away from that. There are other points on here that you can plot out. Like you can just plot out any of these points and solve for them. And you can do Pythagorean theorem to get those values. But for the purposes of this video, I'm just trying to show why the radius works out the way it does in the combination of just like the x's and the y's coordinates. It's just something that I found particularly useful with that student that I was going over on these types of questions. But ultimately, it does come back to like thinking about this as a distance, and if you can get rid of the x part, then the y's part is easier to think about, or if you get rid of the y part, it's easier to think about just what's going on with the x's. So yeah, that's my tip on how to think through these types of problems. A little bit of guess and check work, and you can see what you're trying to do is eliminate the x or the y from the equation, that part of the equation, and just think about the other component. Yeah, a bit different, but it helps you understand why the I think it's x minus k or h squared plus the y minus k squared is equal to the radius squared. It's basically if you have k minus k, that ends up just eliminating that part of the equation, and then you're able to focus on the other part of the equation. Or if you have h minus h, that eliminates that part and lets you focus just on what's going on with the y in terms of some distance.